Welcome to the feedback on the two exercises we ask you to look at in order to help you confirm your understanding of the material we covered in Module 1. Feedback on the Module 1 extension exercises will be provided at the end of the course. In the first exercise for Module 1, we asked you to look at the options for a boundary for a domestic dwelling. In the first instance, let's imagine that we're referring to a suburban house on a block of land that's sufficiently large for a front yard and a backyard. The house is set back from the road, and between the road and the house there is a footpath and a nature strip. But first, a bit of revision. Remember that a boundary is essential because it allows us to understand which elements are included as part of the system. In fact, you could say that it's actually the boundary that defines the system. That is, the boundary defines our system of interest. Elements on the inside are part of the system, elements on the outside are not, and the connections across the boundary are our external interfaces. Note that the boundary is also of interest to the project manager, who's interested in project scope management. The boundary, therefore, defines the scope of the project and therefore is of great interest to the project manager. While a boundary is important, even in a system that's relatively easy to describe, such as the case in a domestic dwelling, the definition of the system boundary can vary quite widely. Now, that isn't necessarily a bad thing. It forces us to be precise, to be very certain as to what is part of the system and what is not. So a formal focus on the boundary definition is always important in any system. Let's have a look at what options there might be for our dwelling. The first option might be to define the house walls as the boundary of the system. That of course assumes that the owners own the entire house. If they share the house, we'd have to draw our boundary around that bit of the house which they owned. So let's assume they own the whole house. As a system boundary though, the house walls are probably a bit limiting, because the boundary doesn't take into account any carport or garage, or any veranda or porch or deck that might be attached to the house. Using the walls as a boundary is also a bit limiting because they don't recognise that the owners also own the yard and the fence, both of which they probably want to include as part of their system of interest. A more likely solution is to extend the boundary out to include the yard, using the surveyed boundary, that is the piece of land that is legally owned. Still, we have to consider a few issues. First, the fence line is shared with 3 neighbours, who will each have a shared ownership of that portion of the fence. Of course, most countries have standard legal arrangements for the fence between our system and our neighbours' systems, so we'd have to conform to those. Most commonly, as you know, the fence line between the 2 houses is a shared responsibility. It may be complicated further by some council constraints. For example, in Canberra in Australia, a front fence is not allowed, so the legal limit of the surveyed land would have to form the system boundary at the front of the system. In many countries too, the nature strip and the footpath are the responsibility of the homeowner, or at least to mow the grass on the nature strip or to clear snow from the footpath. So we may also need to include that aspect as part of our system boundary in those countries. Now, in most cases, that would be as far as we need to extend our boundary. In fact, the most we'd need to extend our boundary. The local council is no doubt responsible for the road. Now, so far, we've really only considered one sort of dwelling. In your exercises, you may have considered others. Notice that our boundary will be quite different if we consider a different sort of dwelling. Consider an apartment block where there are 4 apartments on each floor sharing a common foyer. In the case of an apartment, we might be quite happy with the walls forming the boundary of the system because we don't have that additional complication of the yard and the fence line. Still, we have other things to consider. We need to worry about the shared responsibility of the foyer and perhaps even of the lift. And some of our systems will be in the basement, which means we have to include the car park and any storage areas that belong to us. Of course, such arrangements will be different again in different apartment blocks in different countries. In the second exercise, we ask you to look at the different ways you can describe a system, functionally and physically, or logically and physically. Looking at the functional or logical descriptions first, you should all have produced quite similar lists of functions because we all require our dwelling, regardless of where we live, to perform similar functions. But first, again, some revision. Remember, we discussed that the 2 descriptions are valid independent descriptions of a system. And it's very important that the system is described both logically or functionally and physically. Focusing first on the logical description, because, well, that logical description is the what what we require the system to do, and it's from that that we can then develop a series of candidate physical descriptions. And one of those physical descriptions will be finally chosen as our preferred physical solution. The second reason is that we mustn't allow the way in which we implement current systems in a physical manner to colour the way in which we might describe future systems. We therefore focus on the functional description first, and that allows us then to do the next issue, which is to be able to do the upper level trade-offs and feasibility analysis that need to be conducted at the logical level before we go on to do the physical implementation. The next point again that we covered was a logical description is ideally suited to the interface between systems engineering and the business case, and so it's a very useful communication between the business and systems engineering. And finally, of course, we mentioned that the logical description changes slowly. The physical description, particularly these days, and particularly in things like information technology, changes very fast, particularly as the change of technology quickens. In the development of a system, therefore, there are at least two architectural views, a system logical architecture and a system physical architecture. Now, these two descriptions are of the same system, so naturally they must be related. Looking at the functional descriptions first, you should all produce quite similar lists of the functions because, as I said before, regardless of the country you live in and regardless of the type of accommodation, we all require our dwellings to perform fairly similar functions. So let's look at those sorts of functions that you would have identified when you considered your dwelling. Well, of course, first and foremost, we seek shelter. So we want warmth, cool, dry, and secure environments. Then we'd need other major functions. We need to sleep, we need to eat, we need to rest, we need to conduct ablutions, store our goods and possessions, and of course then followed on by the slightly less important functions perhaps of entertaining, of socialising and of playing. We may also wish to park our vehicles and in some cases do some work and some exercise. Or we may also wish to support any hobbies or other interests that we or our family may have. We may also wish to swim if we live in a hot country, and we can afford to include that function. Note that these functions do not say what sort of dwelling we're considering. They could equally apply to a shared house, a small house, a large mansion, a small apartment, or perhaps even a tent, although if the tent's a physical solution, we might have to forget about the swimming function, except perhaps in heavy rain. Also note that we know from thousands of years of experience what sort of physical solutions are actually available to meet our functional needs. For example, we know that sleeping implies some form of bed, most likely in a bedroom, even if it's shared. Eating would normally involve some form of table and chairs in a kitchen or perhaps a dining room, and so on. Now that leads in nicely to the physical descriptions of our dwelling. However, unlike the functional descriptions, which will be very similar for the types of dwelling each of you will have considered, the physical descriptions are probably quite different depending on what sort of dwelling you had in mind when you began to describe it physically. But let's go back to our suburban house as an example. So for that suburban type house, we have the walls, the floor and the roof, as well as bedrooms, bathrooms, storage rooms, kitchens, and so on as the basic physical building blocks we might use to describe the system. A large house may also have a pool, perhaps even a gym. It may even have an outdoor kitchen, and so on. Notice that some of the above will be similar for an apartment. That is, there'll be walls, floor, roof, and there'll be bedrooms, bathrooms, storage rooms, kitchen, and so on. Although many of those might be smaller, and some of those functions might be combined. The apartment may not have room for its own gym or its own pool, but it may have a small outside entertaining area on the balcony, and it may also, of course, have a shared gym or a shared pool in the apartment complex. Well, we hope you enjoyed the Module 1 exercises. If you want to investigate further, you may wish to do so in the Module 1 extension exercise.